Thank you very much for coming. So this talk is about multi-cluster observability with service mesh, navigating the sea of metrics. I'm Ryota Sawada from Upsider. And before we get into the details of the actual talk, I'm going to go through a quick agenda. So first introduction, quick introduction by myself, about Upsider, the company I work for, and what this talk is about, and what this talk is not about. And we'll go into observability with service mesh with some standard setup, and then we'll look at multi-cluster scenarios. And that kind of leads us to the multi-cluster challenges that we want to kind of familiarize ourselves, and a quick review of key projects that we'll look at for the live demo. With a demo, and then we'll have a quick recap and some considerations to make for the multi-cluster environments. And the slide is available at this URL, dub.sh, with Civil Navigate EU 2023, MCO, and MCO stands for Multi-Cluster Observability. So with that quick introduction of myself, so I'm Ryota, and I'm a principal engineer at Upsider, and I'm passionate about learning, building, and sharing all things technology, and that's why I'm here. I have a son and 2 cats, and you can see quite a few kind of cat images with my slides, I guess, and the picture on the bottom right corner is what I use for basically everywhere. So if you see that, that's my cat and yeah, my profile. And you can find me at usual places with RYTSWD, which is my name without vowels. And about Upsider quickly, so it's a fintech startup providing B2B payment solutions adopted by 20,000 plus companies. So it is a startup, but it's been there for a while. Headquarters is based in Japan, and the business is mainly in Japan, so you may not know about it, but yeah, the business is mainly there. Remote teams all around the world, and I myself am based here in London, and a few other folks are from Europe. So the business is in Japan, but it doesn't mean that it's only a Japanese company, like operating only in Japan. We have been cloud native end user for a while, from early 2019, and we deploy multi-cloud and multi-cluster system in production. So that's why we wanted to kind of bring you what we have learned over the years, and yeah. And we are hiring, so if you're curious, yeah, come hit me up. And before we get into this about the talk, I've given similar talk at KubeCon EU a few months ago. So quite a few things are similar, but last time at KubeCon, the demo didn't work. And I hope that the demo works today, so hopefully, fingers crossed. And I did have technical issues with the devices at that time, so hopefully things go smoothly. So far, so good, hopefully, fingers crossed. But so, prerequisites. So for the talk, we're going to be about observability and service mesh, so I would like you to kind of have a basic understanding of what observability is really about, service mesh is about, but essentially we're going to be looking at the metrics part of the observability. Obviously there are traces, logs, and other stuff, but we'll be looking at metrics. And also from service mesh point of view, there are a few things that you can get from service mesh, but we will be looking at observability specifically. If you are to get more from service mesh, obviously you can, but yeah, observability is one aspect that's pretty complex by itself, and what this talk is about. So we're going to look at service mesh behaviors in a way from observability perspective, especially with the multi-cluster scenario, and observability challenges along with it. We'll look at our learnings at Upsider and kind of dive into the sea of metrics that kind of matches the title of the talk. And obviously with the multi-cluster scenario, it's not about just observability. For metrics with Prometheus, we will look at, but a few other things that we need to kind of consider. And this talk is not about Istio deep dive, and this talk is not about Prometheus deep dive, although we will touch a few things here and there. And it is not a silver bullet setup. So I will be demoing some setup that we use at Upsider, but it doesn't mean that that's the only way or that's the way that everyone should deploy. It's one way, and it's something that you can hopefully learn from. And the slide was available with w.sh, and the repository contains all the demo setup at github.com, RYTSWD, Civil Navigate EU 2023. I'll come back to that repository in a bit as well. So observability with service mesh. So standard setup we're going to look at. So what does observability really look like in service mesh deployment? So if you have just a few application containers in the cluster, on this right, you can see like 2 clusters with nothing essentially, but just 3 containers. We'll look at one cluster and see how it really looks with Istio in place. So deploy Istio and Prometheus, visualize all the connections just to see what it looks like with observability perspective. So first of all, deploy Istio control plane. So if you deploy Istio, what happens is that you will get sidecars in most of the scenarios. There are a few other things that happened in the recent years that Istio doesn't have to have sidecar, but I'm going to talk about that in a bit. But in the standard setup, you would get Istio sidecar, which is an envoy. And from that point, Istio control plane connects to each sidecar to tell the routing details, credentials, metrics, etc. So you can see the purple lines coming through from Istio control plane down to the Istio sidecar. And at this point, Istio data plane can finally connect to each other, connect to each pod. So without that, nothing can connect to each other. And you can see that this white line kind of represents the connection between application from application standpoint. And if you deploy Prometheus, it doesn't really connect to the application per se. It's not going to call application endpoints. If you wanted to, you can, but the idea of Prometheus is to scrape metrics. And if you deploy Prometheus in this environment, it is likely, if you configure it in a way that you want to get the details from Istio, you would have Istio sidecar along with Prometheus on the top left in the cluster 1. So you can see the Istio control plane getting or sending some information about routing and metrics and credentials, and Prometheus will try to retrieve the metrics from each sidecar with these orange lines coming into each of the sidecar to get the metrics about not uptime, but the request time and how many requests coming through and stuff. So only 3 pods in a very simple deployment, and it's already difficult to kind of navigate what it is happening. And if you were to deploy Istio Ingress Gateway, there was a talk like two talks ago about Gateway API, which was really interesting. But if you were to look at Istio Ingress Gateway, we can also see that the complexity goes a little bit more difficult to navigate through. This is because that Istio does have to talk to each of the Envoy sidecars, and also there will be more metrics that will be associated with each connection and each process. And it was already complicated, but we're going to look at a multi-cluster scenario. So let's add another cluster and deploy separate Istio. And this is not the only pattern. You can have one Istio controlling multiple clusters, but this was one way that's kind of easy to see what Istio really does. And this is what we do at Upside as well. So if you were to visualize that in the next slide, we'll see what it would look like. But from multi-cluster point of view, why do we do it? We want to have better HA, better high availability, and higher uptime, obviously. Multi-cluster would allow us to get multi-cloud and multi-managed Kubernetes. So you can have Kubernetes from GCP, AWS, Civo, whatever, and you can connect them all together. And also, you can migrate one workload from one cluster to the other. So if you were to have Kubernetes upgrade, for instance, from version 1.26 to 27, or so on and so forth, you can deploy the application into the new cluster and then kind of gradually migrate and then shut down one of the old ones later on. Obviously, there are a few other cases with the multi-cluster, and at Upsider, we use several multi-cluster scenarios, but one of them is that because we are a fintech company and we are regulated, we have to make sure that some of the data is better managed than other clusters, and we have to have some compliance checks handled. So from that sense, we have a specific cluster where we deploy certain applications that deal with like credit card information, personal information, so on. So those clusters will be tightly regulated, but other clusters can be a little bit more, loose. So with the multi-cluster, so let's say we're going to deploy Istio control plane and then Prometheus. So you can see kind of up at the top, you can kind of see the same thing with the Istio control plane being placed, and the Istio sidecar will be placed in each of the application along with Prometheus there. And deploy Istio ingress gateway, which is crucial for multi-cluster to work. And it's basically identical at this point. Obviously, it doesn't have to be. You can have different applications, but you can also have completely exactly the same application so that you have two clusters to host the exact workload that you can actually potentially have from one cluster. But let's see how that connection works. So if you were to connect from cluster 1 at the bottom to connect to cluster 2, any applications that we run in cluster 2, we can connect to it using Istio ingress gateway. So any traffic from application 1 at the bottom, for instance, would go into Istio ingress gateway at the top, and then further up into any applications that you need to connect to. So that connection is how the multi-cluster works. And if you were to visualize all together, yeah, it's pretty messy, but like you can see that the messy part is not just at the bottom part. If you were to have multi-cluster connection between two clusters, it would be much more messy. And if you have more than two clusters, it would be difficult to kind of visualize at this point. So we're going to look at multi-cluster challenges. So we saw the Istio ingress gateway kind of playing a crucial part. But when it comes to multi-cluster, there is this inter-cluster traffic. Intercluster traffic means that cluster 1 connects to cluster 2's application. And if you have multiple of them, obviously that becomes more and more difficult. When traffic leaves from cluster A to B, who is it that needs to look at the metrics? So you can have multiple clusters doing multiple metrics setup. So you can have cluster 1 doing its own observability dashboard and setup. But if the traffic goes out of cluster A or 1, how do you get the data from cluster 2? Or do you want to get that data in cluster 1? Or what happens if you were to connect to 3 clusters, cluster 1 to 2 to 3? If you want to get the cluster metrics from cluster 3, you don't really get connected from cluster 1 perspective. You only have that as a dependency pipeline. You only see that in a chain of metrics, but you don't actually see the pinpoint. You can't really pinpoint the metrics, and that could be a challenge. Obviously, there are a few ways to do it, but it's definitely worth mentioning about the challenge. And cardinality. Cardinality is not a problem for service mesh or multi-cluster per se. It's more about the observability as a whole with metrics. But if you have multiple clusters, it means that we have more metrics that we need to digest. So cardinality could be a challenge, definitely worth looking into what we can do, what we need to deduplicate, what we need to handle in terms of retention, like we don't want to retain everything. And that kind of goes into the next point about retention. So latest metrics can be fetched from running process of Prometheus, but you obviously want to go back in time to compare. So if you were to do that, metrics need to be retained in some historical setup, but the retention, again, will be a question of whether we want to have in the cluster 1 or cluster 2 or somewhere else. Do we want to retain as a whole, like all together, or do we want to have them separately? It doesn't mean that there is one solution, but there are a few ways to go about it, and you have to pick what's right for your business use cases. And it's not the final challenge, but one of the final ones for this particular talk is about data source. So because you have multiple clusters, it's possible that your application is running in 2 clusters or 3 or multiple clusters. You need to know where the metrics is coming from, and you need to know the data source. So if you have application 1 deployed in 2 clusters, you can get the metrics kind of combined and made in a way that's available to you, that you have this request uptime and 99%, everything is going well. When something goes off, is it from cluster 1 or cluster 2, or is it actually going off from, because of the application deployment, the version didn't really work out? That data source is crucial actually to understand what's happening in the cluster from the observability perspective. Otherwise, it will be difficult to really pinpoint where the problem is. And before we get into the live demo, quick review on key projects. So Istio is going to be the one that I'm going to be looking at. It has graduated finally in July, and it was boasting about fastest CNCF project to graduate, although it's been a while since the version 1 came out. I think it was just a bit late for the incubation, which happened in September 2022. But at least it's graduated, it's well adopted and documented as well. So it's definitely something that you can run in production, and we do at Upsider. And Istio is about service mesh with Envoy, and we're not going to go into all the Envoy details, but MTLS and multi-cluster models are something that you need to be aware of if you were to go down the Istio path. There is this sidecar and ambient deployment, the new deployment scenario, which you don't have to have the sidecar, but I'm not going to be talking about that. It's still, I think, a beta, or I can't remember if it was alpha, but it's not fully production ready. For Prometheus, it's a graduated project. It's a second to graduate after Kubernetes, and pretty much I'm pretty sure that most of you have touched on it or played with it or use it in production all the time. And we'll be looking at Prometheus operator for multi-cluster scenario. The reason is that we need to have multiple Prometheus instances running for kind of handling all the metrics and cardinality and all the challenges with the metrics. Related projects are Thanos, Cortex, and Grafana, and that leads us to the next project, which we'll be looking at with Thanos. So Thanos is for the long-term storage for Prometheus, and there is deployment model of sidecar or receiver and a few other things that you can do with Thanos. Thanos is, I would say, it comes with a variety of items, but it's simpler than some of the alternatives, and that's the reason why I'm going to go with this Thanos for this particular demo. And Thanos is very good at querying performance, and which we would be able to hopefully see in a bit. So going to have a quick overview of what the demo is going to be looking like. So we're going to have 3 clusters in Civo this time, and 1 cluster to be a central observability cluster. So we're going to have 2 clusters which would have multiple applications deployed, and 1 cluster would serve as observability central cluster, which we would try to get all the information into 1 cluster. So from Istio point of view, deploying using manifest rather than Istio control, which I'm going to talk about a little bit more. Multi-primary for the network setup. This is important for the observability as well, so that you need to be able to get the certificates and deployment in a way that's managed per cluster. So if 1 cluster goes down, it doesn't mean that everything goes down. You can have multiple clusters kind of providing the HA. We'll look at sidecar as well, and non-demo profile, so that it's a kind of a mock of a possibly production-ready setup. And from Prometheus point of view, we're going to use Prometheus operator, as I said, and Prometheus will have multiple Prometheus instances in some of the clusters. Some clusters can have just 1 Prometheus and may not need Prometheus operator, but hopefully this gives you an idea of what you need to do to really tame the possible difficulty with metrics and the observability aspects. And we will have the remote write, and along with Thanos deployed as sidecar, and we're going to use Helm. So with that, I'm going to go into the demo, and before that, let me go to my GitHub repo. So in the repo, there is this demo.org file, which is basically a markdown file, and it's got all the steps to follow along. So if I were to look at, there are some prerequisites and some of the steps to go through one by one. And I wanted to show one more thing. Oh yeah, I need to create cluster. So let me go into Civo. I'm going to create a new cluster called cluster 1 because I can't name things really well. So I'm going to try to create a new cluster 1 and going to go into Kubernetes with version 1.27 and going to create cluster. So Civil cluster is very quick to start up, and it's all managed. So I thought this was the perfect solution for the demo, but you don't have to use this. You can have other clusters like Kind or other like GCP, AWS, whatever that suits your needs. And for this one, I actually, because it does take about 2 minutes, I wanted to save the time by creating some clusters. So backups are when things go horribly wrong, backups going to work. But cluster 2 and 3 are completely empty that I created a few minutes ago, and cluster 1 is being created. So while that's doing that, let me get into the demo steps. You can see this, right? Yeah. So this is exactly the demo.org file. I'm just viewing that from Emacs. I'll be talking about why. But the demo steps are going to be just copying and pasting the bash script or bash commands to create directory or copy some of the files. And for this demo steps, all the demo actual setup will be available by running just demo.sh in the repository. But for this one, I just wanted to take the time to actually go into each detail. And for the reason why I'm using Emacs is that I don't want to copy and paste, so I wanted to save the time by just being able to click on or just kind of provide some command to run the shell commands. You definitely don't need to have Emacs to go through all of that. So prerequisites, as we saw just earlier, kubectl, customize, and Helm. So this one particularly don't use Istio control, although we are going to deploy Istio, just so that we don't have too many moving things and too many things that we need to worry about. Obviously, you need to know about Istio, but Istio control is another layer that you need to be kind of familiar with if you were to operate and install, but just taking that out from the picture. And with that, so let's get into the demo steps. So first of all, want to start from scratch, so I'm going to create a new directory. So I create a new directory. I'm just providing some command to run this, what is it called, bash setup. So making directory in the temp directory, cd into it, and then ls, just nothing in there. So it's clear that it's a clean setup. And for the setup, there is a GitHub repository, rytswd, that's my username, and then civil navigate EU. So the whole exact setup is there, and also the manifests are there. So there is nothing that's outside of the manifest that we're going to deploy. So you can see the exact manifest to see what's working, what's not working. But for this particular demo, I want to pick all the files from that repository. So I'm just doing a curl to get the tar.gzipped version so that I don't have to do git and I don't have dependency to git. And I'll be just taking out some files from the repository down the line. So preparing clusters, so using Civil cluster is one approach and using Kind cluster is another. But if we were to use Kind clusters, you need to be aware of several steps. You have to have Kind created with the Docker network aware, and you have to have some IP address set up. So from that sense, I just wanted to avoid the complexity. So I'm going to go into the Civil clusters instead. And the Civil cluster you can create from console, which I did. But you can use Civil CLI, Terraform, Crossplane, whatever you want. But because I use the Civil console, I need to get the kubeconfig, which I'm going to get that from the web console. And Civil cluster 1 is finally up. So I'm just going to click to download the kubeconfig. I think I have already downloaded the other clusters. So what I'm going to do is, it's just assuming that the cluster is named cluster 1, 2, 3, and I'm just going to try to move that over to my temp directory. Everything is available now, and I'm going to try to set up the kubeconfig. So I'm not going to have anything else. I'm going to start a brand new kubeconfig setup. Nothing comes out, but that means that if you were to quickly look at the cluster situation right now, so cluster 1 has nothing, some Civil stuff in kubectl system, cluster 2 the same, cluster 3 the same. So nothing is deployed at the moment. Hopefully things will work out in this demo. So moving on, so we have to have the multi-cluster to actually connect first of all, before going to any of the observability stuff. So we have to make sure that the connection can be made with the certificates in place. What the hell just happened? Let me just get out. Come on. Yeah, so I'm going to start with copying the CA certificate creation tool from Istio. You don't have to have this, but it's just an easy way to get started with. And this one takes a little bit of a while. And once that's available, we're going to create a cluster certificates so that the multiple cluster can talk to each other based on the root certificate that we create here. Obviously, you can have other certificates created elsewhere, but this one is an easy one, especially if you were to test it out on your local machine or your demo environment or some playground environment. You can just create certificates in this way. And is this working? Is this downloading? I think it takes about like 20 seconds to download all the Istio tools, so this might take a little bit of a while. And I think it just did, or did it not? Something is happening. Let me try to, I think what's happening is that, there you go. So it's actually worked. So the certs directory is created. And if you look at the certs directory, which is the copy of Istio/Istio repository, which has makefiles. Nothing complicated, just makefiles. So what we're going to do is to use the makefile to create the root certificate. And that goes pretty quickly. And then within the certs directory, we can now see that root certificate being created. And we'll go into creating the intermediate certificate, which means that we're going to use the root certificate to deploy to each cluster. So if you were to have 3 clusters, you have to have 3 intermediate certificates. If you were to have more than 3, if let's say 10, you would have to have 10 certificates, somehow mapped to the same root certificates. And that's the kind of required setup for MTLS and connection with multi-cluster. And with that in place, I'm going to start creating Istio system namespace because we got the certificates in place, and then we're going to deploy that certificates first into the cluster. And it's a simple kubectl create secret based on the certs files that we created for cluster 1, cluster 2, cluster 3, and all the secrets are created. And the next step is to go into Istio control plane. You can do a few things with Istio, but for the simplicity's sake, I'm going to go in with manifest, and you can see all the details, why this was chosen and what other options that you have. But what I'm going to do is go into get the Istio installation manifest. So it's in the repository of the Civil Navigate EU. And then this would create this particular command. Would just pull out the Istio manifest installation spec, and you can see that some cluster specific installation specs are available. So you can see the exact specs. This way, there is nothing moving parts and hidden implementation details in that. So with that, before deploying Istio, label the namespaces so that they know that they are connected to multiple clusters in the different networks. If you have more single network and Kubernetes deployed in a single network, you don't have to do this, but this is a requirement if you were to have multiple. So, and with that, I'm just going to deploy Istio with kubectl apply or kube control apply, and that would fail. I should see an error. Because the CRDs are part of the spec, and I'm getting an error saying that the CRD is not defined, and if I were to just run twice, that error goes away. So Istio control does not have a nice kind of UX that everything is deployed with one command, but actually behind the scenes it's just deploying things and then waiting for things to be ready and then deployed once again. So running things twice is exactly what Istio control is actually doing. And if you have GitOps, for instance, you might have a better setup with the manifest being available or using a Helm chart rather than Istio control. So this is just to demonstrate that it works without Istio control. And with that, I'm going to go into Istio data plane so that we have the connection finally made available between the clusters. So at this point, I'm going to deploy the resources like deployments, stuff like that. So if you were to look at that, a few things deployed for cluster 1, identical deployments for cluster 1, 2, 3, and you can see the actual manifests in the repository. And if you were to go further into establishing the multi-cluster connections, we just deployed the Istio components. So Istio components are now available, and if you were to quickly look at, so you can see the Istio, hopefully you can see this. Yeah, Istio East West Gateway, Istio D, things are deployed, but they don't know each other. So we need to make sure that they know each other by providing this YAML file so that they can connect to each other using this TLS, MTLS setup. And this YAML file is also part of the manifest directory. So what I'm going to do is to pull out the manifests, go into manifest directory, Istio usage, and then there is this cross-network gateway YAML, which is actually just a straight copy from Istio documentation. And I just prove that it's available in the temp path. And then what I do is just apply that temp path into the cluster. This should take a second to apply. And some CRDs, custom resources are created. Based on that, we now going to go into establishing the connection between clusters. So cluster 1 needs to connect to cluster 2, and vice versa. Cluster 2 needs to connect to cluster 1. If you don't want to do that, you can just have single connection with cluster 1 connecting to cluster 2. But what I'm going to do is to go with the kube control command with some secret setup so that cluster 1 would then know about cluster 2. So just a few things, one thing created, annotated, and labeled, and that's how the Istio controls mechanism about connecting secret works. So I have a quick show note of Istio control create remote secret is the official way, but behind the scenes it's not, it's nothing complicated. It's actually doing the secret, annotating it, and labeling it. So what I'm going to do is to connect cluster 2 to 1 as well, and if I can go down further, I'm going to go cluster 1 to 3 as well. And finally, cluster 2 to 3. And if you were to use kind clusters instead of civil, you can do that. Yeah, we're not using kind clusters for now. So with that in place, now going to observability setup. So we're going to create a monitoring namespace. And we're going to deploy Prometheus in all the clusters. And well, first of all, what did I do? So I made sure that the Istio will take place in terms of the deployments. And as I said, Prometheus is also available in the repository. So I pull out the manifests for Prometheus and then install Prometheus operator in each cluster. So it's essentially a simple manifest with operator being installed in cluster 1, 2, 3. And everything is installed. It's quite lengthy, so I'm going to hide that. And from there, I'm going to deploy 2 Prometheus instances. One is for connecting to Istio processes directly, and this one is Istio collector, which I named. You can name it however you want. But Istio collector would look at every metric, and that's going to have a high cardinality. It's going to have so much data. So for that, I'm going to have another Istio federation, which is going to cut down some of the metrics that we don't care about. For instance, Istio specific version details. Perhaps you may want it. You may want it, but perhaps you don't really need it. So from that sense, I'm going to deploy 2 Istio, Prometheus instances. Kind of one to go directly to Istio, and then another one that's kind of aggregating all the data behind the scenes. So that's all deployed. And with that, just a couple more steps. So install Thanos. So that this one is to install Thanos only for cluster 3, which is going to be the central observability cluster. The central one is going to get all the details from other clusters, but we're not going to retain all the metrics in each cluster. Instead, we're going to have one retention area with Thanos. And with that, we're going to install Grafana just to be able to see what's going on. And Grafana, also another one with Helm install. And for Grafana, you can have this dashboard as you like. For this particular demo, I have a sample dashboard and data source set up. So I'm going to configure Grafana to use that, just a config map and secret. And with that in place, I should be able to get the Grafana up and running. So Grafana, if you install it from Helm chart, you would get the kind of a random password generated. So this is going to be the password. And if I were to do port forward for 3000 against Grafana 80, hopefully this is going to open up Grafana. It's a good sign that it's opened up. Admin, and then copy the password that I have just got from the command from Helm. So Grafana is up, and if you were to go into the dashboard, you can see that the multi-cluster dashboard is in place. You don't see anything. The reason is maybe that the connection is just about to come in. So if you were to look at the deployments, cluster 1 having Prometheus, cluster 2 also having the exact same setup, and cluster 3, okay, Thanos is not coming up, and Thanos has finally come up, so this means I should be able to see the metrics coming through. So with this setup, you can have multiple applications deployed in cluster 1, cluster 2, and if you really wanted to, you can have applications deployed in cluster 3 as well. But for this particular demo is to make sure that you have one place to go to, and that allows you to kind of navigate through all the difficult different metrics from different clusters. And if you have the data sources in place, you can obviously navigate which one is having trouble. For instance, cluster 1 is having some high load that the cluster 2 is actually doing much better, then you might be able to figure out, okay, you need to investigate further into cluster 1. And how this is done is in the repository. Where is the repository? This guy. And if I were to go into the manifests, just quickly for Prometheus, for Istio collector is to actually just get all the information. The federation is probably the more interesting bit. Installation is just a simple installation with, which one is this? Simple Prometheus CRD with Prometheus operator, but there are a few things that happen with Istio specific annotation. So if you were to really use Prometheus with Grafana and Thanos and Istio, you may want to look at these manifests to see what are the key aspects that you want to integrate. Some of the items I should have most of the special setup in some comments. So yeah, that should be a reference point, hopefully. So with that, I'm just going to go back to the slide. And a quick summary of what happened. So the complexity of multi-cluster deployment was, first of all, deployment was very complex. And few clusters only was already quite a bit to comprehend. And multi-cluster is definitely made easy by service mesh, but Istio definitely helps in that regard. But observability is actually made more difficult because of the service mesh and because of the multi-cluster setup. And it's not to mean that observability is made difficult because of Istio, it's just that the multi-cluster is difficult from observability perspective. Central observability cluster was something that I stuck with, and this is how we do at AppSider. So we have one place to go to. We can look at multiple clusters, and we can see exactly what happened and what's causing the problem when there is any problem with some of the stacks. And it could be just one cluster. It could be every cluster, depending on the situation. But if you have one cluster to go to, if you have one dashboard to go to, that's one way. That's not the only way, though. And multi-cluster observability challenges, you can see some of the details about the data sources, intercluster metrics, and all of that in the repository, as I show here. And it is worth noting that Istio is not the only solution. Thanos is definitely not the only solution. And Selim, Envoy, and other tools available. For Thanos side, we actually use Thanos at AppSider, but we have moved on to Grafana Mimir for our use cases. It just made more sense for us. But they are definitely, all of them are very capable. And finally, some other considerations. Alert management. If you were to have alerts, you might want to consider having alerts per cluster. So you might actually need to have other metrics setup, other metrics handling setup per cluster than just having the central repository. Because if you have a central observability cluster, if you do have central observability cluster, that means that nothing is actually a real time. It would feel like real time, but it could be like 5 seconds or 10 seconds delay, and that may cause some trouble with alerts. And configuration management, we use GitOps at Upsider, and we didn't use GitOps just to show that everything is, every step can be gone through with the scripts very simply and without any Istio control or anything like that. But if you were to have everything managed with other applications, I would definitely encourage you to manage everything with GitOps. Other aspects are shown here. Multi-tenancy would be a consideration if you were to go down that route, if you have that requirements, and OpenTelemetry is another thing that's coming up. And with that, final appendix of other talks. So there's another one, observability. From observability perspective, there are 4 talks I could find. So one happening right after this, one happening upper sugar right after this as well, and 2 from tomorrow. So definitely check them out. And some references for the repository, the slide deck, and special thanks to my colleague who worked through the demo. And with that, thank you very much for attending.